Hi, my name is Cody Parker. I'm a postdoc at the Cyclotron Institute at Texas A&M, and I'm going to tell you about the Texas Active Target Time Projection Chamber, or simply TexAT. So if we take a look here, this is the TexAT chamber, and it's installed on the Mars beamline at Texas A&M. This is where it performs the bulk of its experiments. However, we have also packed TexAT up and taken it to Triumph, which is in Vancouver, British Columbia, and we have also taken it to Ohio University in Athens, Ohio. And I know it looks a little bit different in size in each of these photos. So here's a photo of myself to help you get an idea of the scale of how big TexAT actually is. And so what is TexAT? So if we pretend that we're a beam particle coming into the chamber, the first thing we'll do is pass through an ion counter. And basically this is for the beam identification and normalization. Next, we'll enter this central part, which is our time projection chamber region. And in here, we have what are known as micromegas, as well as GEMS, or gas electron multipliers. And this helps us read out the signal of the energy loss of the particles as they travel through the center. And so basically what we can do, because of our readout segmentation, is we can actually get not only an XY track of the event that has occurred inside the chamber, but also a full 3D track reconstruction when we take into account the drift time inside the chamber. However, not all of the particles will be stopped in the gas, and so on the back, we have a silicon plus cesium iodide telescope wall. And so we can also use this for further identification of particles based on mass and energy for the reaction products. And to read all of this out, we use what is known as GET, or General Electronics for TPCs. Basically, this is a way to have the best cost per channel, and these are specifically made for TPCs. There are other ones throughout the world that utilize this setup. TexAT is very versatile, so I have some things highlighted in this box down here for past experiments. One of the things I'm very excited about would be this bottom line here, where these were the first neutron-induced reactions using a TPC. And you'll notice that there's all sorts of nuclear structure work, as well as beta-delayed particle spectroscopy, fusion reaction experiments, transfer reactions, kind of you name it, TexAT could probably find a way to help get that experiment done. And kind of the motto of have TexAT will travel, I do want to highlight that we have a PAC-approved experiment to take TexAT to RECAN, hopefully later this year or early next year, depending on how that beam schedule works out. So thank you for listening about TexAT.